Alright, so we're going to try out this experimental style with the dual frame. Okay, so what I'm trying to do is I'm trying to verify the calculation for charging a capacitor. As nerdy as it sounds, basically a capacitor increases its charge by 63% of the remaining empty space every time constant, and the time constant is the capacitor size times the capacitor size times the resistor. So right now we have 1,000 microfarad capacitor with a 10,000 ohm resistor. So the time constant should be 10,000 times 0.0001, which should equal 10, or like, no, not 10, like 0.1, inverse of 10. So, yeah, I just wanted to verify that it should take about, a capacitor with a time constant of 1, which would be 1,000 microfarad capacitor with 1,000 ohm resistor, that should take about 5 seconds to charge. So I'm guessing because the resistance is 10 times that this will take 10 times as long to charge. Okay, so if I haven't bored you yet, alright, then, and you're still excited about this, let's get started. Alright, so what I'm going to do is I'm going to push the button off the camera, and this might be a little bit difficult, so I need to put, what I'm going to do is I'm going to actually start, and we'll just subtract the time that it took to start. Just had some white chocolate macadamia nuts, and apparently it's making me cough. Okay, so I'm going to start it. And as soon as it goes, okay, boom. Oh shit. Well, there goes my plans. Okay, so let's start that over. I'm gonna short the circuit where the capacitor is. Hold on, I still have to understand that myself. So basically what I think I'm doing is, in order to deplete the capacitor, is I am I really don't understand like why that depletes the capacitor. Because yeah, that's definitely what you call shorting. Okay, so it takes instead of connecting the capacitor to the rest of the circuit, it just creates a tiny loop where that black wire is, like right there, and it goes around to the red wire up top, back through the capacitor, and then back through the black wire, and then back to the switch. Instead of going through the entire circuit where it can gain more charge, it just loses, it just depletes its charge right there. Okay, so we're gonna try this again. So, okay, so as soon as it starts, I'll explain what I'm doing after I start. Okay, so like we started at about 6 seconds there. I didn't really have someone else to tap the button, so we'll just take like 7 seconds or so off. I'll be able to be more precise when I look back at the footage. Okay, so like I said, this should take about 50 seconds to get to 9 volts. And the reason is it should increase by 63% of the difference every so it's a little bit faster than that. And I get it. If we hold it, we'll keep going. But then again, the reason it's a little bit faster is because the battery is actually like 9.4 volts, not 9 volts. So that does make sense, and I think we're just doing a little bit of overkill here. All right, so it definitely became fully charged at about 50 seconds, which is fun. And by the way, why do we need to know this? Well, I am just getting started in this myself, but here's my theory on why we need to know this. It allows it allows pulses for things. So like the reason I'm learning this now is I'm learning like how clocks and timers function, and I'll be able to like create like timed things, I guess. Like those Christmas lights that alternate back and forth. That's a one use for the capacitor. You also need a relay for that, which we've already gone through. I'm just trying to think of like what else like you'd use capacitors for. I'm assuming that you would use it to like build up a giant pulse of charge to start a motor or something. I don't know that for sure. I'm still learning, but yeah, that's I'm still figuring this out. So as soon as I learn a little bit more about what's going on, I'll tell you. But what I do know is that the capacitor is a little like a small rechargeable battery. Like it takes current through here and it charges it up, and it blocks current from the rest of the circuit as it builds up, and which creates a higher voltage at the specific point. So I'm sure if you needed to increase voltage for a specific application for a brief period of time, I'm thinking that's I'm trying to think of like something that you would need to do that for, but I'm not coming up with anything yet. But that's one thing that you could do. So basically, this was just like a fun little thing that I wanted to show you. Like, there's no fancy lights or anything. This is just me trying to measure how fast the capacitor charges, and that's pretty much it. Hopefully you were somewhat entertained, but if not, thanks for watching. I'll catch you later. Like, subscribe if you feel like it. I'm gonna act like a big channel before I am. That's about it. I'm done rambling. Bye.